So this lecture is going to deal with molar mass and how it applies when we have a molecule instead of an atom. So in the last lecture we discussed how we can convert between the number of atoms, or in this case molecules, into the number of moles of something by using Avogadro's number. And remember, Avogadro's number is nothing more than just 6.022 times 10 to the 23rd things per mole. So if we're going from atoms to moles, we want to divide by Avogadro's number. If we have moles and we're going to go back to atoms or molecules, we're going to multiply by Avogadro's number. So here's our conversion factor. Once we have moles, we can find the mass of a substance, and we're going to find the mass of the substance by either multiplying by the molar mass or dividing by the molar mass, depending on the direction we're going. And we've done this with atoms, and so now we're going to say what happens if we have a molecule. So what is a molecule? A molecule is a collection of atoms that move around as a single unit. So it's basically a bunch of atoms that are stuck together by chemical bonds. We can also have an ion, right? So an ion is something with a charge. So this is just a molecule with a charge. So a group of atoms that have either a positive or negative charge. And just like with our atomic ions, we can have a molecular ion. If it's positively charged, we call it a cation. If it's negatively charged, we call it an anion. And later in the semester, we'll talk more about this, but I'll just introduce it now. There's a couple different types of chemical bonds. We can have covalent bonds, where electrons are shared between atoms, and we can have ionic bonds, where the attraction between a cation and an anion is what holds it together. But we'll talk more about that later. For now, let's talk more about the molecule. And we'll start off by what's known as the chemical formula, or sometimes referred to as the molecular formula. And this is a way of shorthand that allows us to write a formula for a molecule. We know some of these. H2O, we all know is water. So what is H2O? Well, here's the formula here, and what that means is capital H subscript 2. It means there are 2 hydrogen atoms followed by an oxygen atom. So one water molecule contains 1 oxygen atom and 2 hydrogen atoms. All right, so that subscript tells us how many of each atom are present. If there's no subscript, then it's implied there's 1 of that type. So now we have CH4, which is methane. So this would contain 1 carbon atom and 4 hydrogen atoms all together in that molecule. So this is one way of representing the molecule by its molecular formula. We can also use the structural formula, and chapter 4 will start us drawing these, where we're going to show how the molecules are connected. How are these atoms connected? And so water would look like this, CH4 would look like this. We'll talk about that in chapter 4. For now, what we want to be able to do is use our molecular formulas to understand what is the mass of this, how many moles of this are present in a given quantity. So, for example, what is the molar mass of one of these molecules? So we talked about we can use the periodic table to find the molar mass of carbon, or we can find the molar mass of hydrogen. But what if we want to find the molar mass of CH4? Well, the way we would do that is we'd know CH4 is made of 1 carbon and 4 hydrogens. So the molar mass of the molecule is just the sum of all of the molar masses of the atoms. And so we can see that in this equation here, where carbon's molar mass is 12.01 grams per mole. So times 1 carbon atom plus 1.0008 grams per mole for hydrogen times 4 hydrogen atoms. So we have to take into account that there's 4 hydrogens, and we get 16.04 grams per mole. So if we had 1 mole of methane, it would weigh 16.04 grams. This is helpful because now we can do our unit conversions again. So for example, if we wanted to calculate the mass of 2.85 moles of methane, so if we know how many moles of methane we have, I'm going to say, what is the mass of that? We can use our molar mass as our conversion factor. So we're going to start with the 2.85 moles we were given, and we're going to multiply that by our 16.04 grams per mole. right? So moles cross off, and we're left with 45.7 grams of methane. In another problem, we can look at and say how many molecules are in 2.6 grams of methane. Now this one's a little trickier, right? Because it's two steps. We can't go directly from grams to molecules. Instead, we have to go from grams to moles, and then from moles to molecules. So we'll start with the 2.6 grams we were given. Here's your 2.6 grams. We're going to use our molar mass as our conversion factor and divide by 16.04 grams per mole. If we stopped here, that would give us how many moles of methane we have. We want to go to molecules, so now we can multiply by Avogadro's number. For every mole we have 6.022 times 10 to the 23rd molecules, right? So that's going to give us a total of 9.76 times 10 to the 22nd molecules. Thank you.